Test 1-2 review for academic. Question 1. Paul withdrew $100 Monday and $200 on Tuesday from his bank account. What value reflects the change in his bank balance? Withdraw. Withdraw means you take out money from your bank account to use it to spend something. Some people enter an ATM, go to ATM, enter their ATM card, type in their 4-digit PIN code, and withdraw money to use to spend on items or whatever, services. So he took out $100 on Monday. He took out $200 on Tuesday. So $100 he took out, $200 he took out. So in total, he took out $300. A is the answer. Be careful. D would not be it. We can say what value reflects the change in his bank balance. His bank balance went down $300 because he took out $300 from his bank in order to spend on items or services. Number 2, on a number line point A, so number line, let me do a number line then. Point A is at 0 and 1/10. That's right there by 0. Point B is at 2/5. 2/5. So what do you remember about turning a fraction to a decimal? How do you read this? 2 divided by 5. You have 2, you're dividing it into 5 parts. For those who have memory issue, I use the word Taibo to help me out. Top goes in, bottom goes out. But if you not use 2 divided by 2 divided in 5 parts. If 5 go in 2, I don't think so. Put a placeholder, bring it down. Can 5 go into 20? Group of 5 go to 20 4 times. So we have 0 and 4/10. So that means B, it will be right here, 0 and 4/10. Point C is at 2/10. So C would be right here, 2/10. And point D is at 3/10. If we have to, I will turn it into a decimal to show you. How do you read this? 3 divided by 10, or 3 divided into 10 parts. Can 10 go in 3? No, at a point 0, because you do not change this place value. Can 10 go in 30? 0 and 3/10. So it goes right here, 3/10. So it's A, C, D, B. A, C, D, A is the answer. Number 3, name a whole number example. 0, 1, 2, 3. I know it says an example, but I'm going to name more. 0 and any positive whole number. Name an integer example. -5, -6, 0, 1, 8, 9, -10, 12. Before you think, I had a lot of kids who really think integers are just negative whole numbers. It's negative and positive whole numbers. So all these whole number examples are examples of integers. Name a rational number example. What's a rational number again? A rational number is any number that can be written as a ratio or fraction. So 0 and 1/10. Can a decimal be written as a fraction? You bet you can. Well, that's a fraction. What about 7? Can the number 7 be written as a fraction? Can you do 7 over 1? Yes, you can. That's a fraction. What about 14 over 2? Would that equal 7? Yes, it can. What about -8? Can that be written as a ratio or fraction? What about -8 over 1? -8 divided by 1 is -8. What about -24 divided by 3? That would be -8. So the table shows the scores of 4 people playing a video game. Which score is a whole number? Well, this is a decimal, crossed out. A whole number is positive, 0, 1, 2, 3, 4, 5, 6. So it can't be Miguel, Sabrina is a whole number. Number 7, plot 0, 3. Again, x, y. The first number tells you look at the x-axis. So 0, y is 3. X, y. X is -3. Y is -2. So it goes right here. Next one, x, y. X is 3. Y is -2 right here. It is, what polygon do you see? I see a triangle. And I think it's even it's an isosceles triangle, I believe. We're going to learn what those are, isosceles. When 2 sides are eyes. How many eyes do you have? 2. 2 sides are the same. Number 8, the table shows the changes in the value of a $51 stock during 1 week. What was the value of the stock at the end of the week. So it's $51. It dropped to 49. It went up 7, 56. Went up 6, 62. It dropped 9. Regroup 10, 11, 12, 53. And then it dropped 16. That's regroup. That's 7, 37. B is the answer. Number 9, write an addition problem for the number line below. So you start at 0, you go back to -5. You go forward 8 spaces. And that is our addition expression. If I ask you to write it as an equation, which we're going to be learning the difference, an expression is just the mathematical problem. It's like a problem. It's like a sentence. And then an equation is with the equal sign. So what is it equal to? 3. 10. Write the decimal equivalent for each fraction. 1/8. I see 1 divided by 8. So 1 break up into 8 parts. Again, if you have a memory issue about this, use Tybo. Top goes in, bottom goes out. So can 8 go in 1? 0 times. Can 8, realign it. Can a group of 8 go in 10? 1 time. That's 2. I need to get rid of this remainder. Add another placeholder, 0. Can 8 go in 20? 2 times. Remainder is 4. I need to get rid of that remainder. Add another 0. Can a group of 8 go to 45? 0 and 125,000. Next one. 2 divided by 5. Couldn't that be written as 2/5? So 2 divided by 5, 0. Can 5 go in 20? 4 times. 0, 4/10. It's the same as saying 2 divided by 5 or 2/5. Next one. 13 25th. That's 13 divided by 25. 13 divided by 25 parts. Can 25 go in 13? I don't think so. So add some zeros at the end. Again, it does not change its value when you put a 0.00. Can a group of 25 go in 13? 0 times. Can a group of 25 go in 130? 4 times. Can how many groups of 25 go into 3? Wait, stop. Let's do that again. Can a group of 25 go in 130? 5 groups. That's 125. Because I knew it was wrong because my remainder was way too big. Can I, bring that thing. Can a group of 25 go in 50? 2 times. So 5,200 is the equivalent. And number 13, how do you know absolute value -3 is 3 and absolute value 4 is 4? Do not say opposite. Oh my gosh, I have all these kids saying, oh, it's the opposite. No, it's not. What's absolute value? Here's the number line. Absolute value, I'm going to plot -3 and 4. Absolute value is how far is that number from 0. You count the number of units. 1 unit, 2 units, 3. It's the distance from 0. So absolute value of -3 is 3, and absolute value of 4 is 4. It's how far is it from 0, distance. Think about it. I think I used an example in my class. We watched the Ferris Bueller part of the movie where they are driving backward. When you're driving backward, I believe they drove like 100 miles backward. So they went backward. Are they still moving? Are they moving from their starting place of 0? Are they still backing up? Are they still a distance away? Yes. You don't say they went back -100 miles away. They drove 100 miles. Because if you look at the odometer, it keeps going up and up. Distance is always positive. So absolute value is always positive. All right, next one, number 14. Put them from least to greatest. I had to draw a number line because from what I remember, it goes from least to greatest. So let's start with a positive, 7 3/4. So that goes right here. Other positive is this one. Where would I go? Well, I can turn this fraction into a decimal. 6 divided by 11. 6 divided into 11 parts. How many groups of 11 go 60? 5 times. How many groups of 11 go in 50? 4 times. So it's going to be about 7 and 54 hundredths. So it goes afterwards. So let's go here. So we have negative 7, and what does this little bar mean here? It's a repeating bar. It means the 6 goes forever and ever. When I was in 6th grade, my teacher, Miss Godaz, I still remember her from Molly Middle School, she told us there was an arrow there. We do not draw the arrow. So that's why it's repeating bar. Then we have negative 7 4/5. What fraction decimal is it? 4 divided to 5 parts. That's 4 divided by 5. Okay, group of 4 and 5 go to 40, 8 times. So it's negative 7 and 8, or 80 hundredths. All right, let's think. Where does it go here? You are counting backwards. Backwards. It'll be 1, 2, 3, 4, 5, 6, 7, 66. So would 80 go before it? It shall go before it. As you're counting backward. So from least to greatest, this negative 7 and 4/5, negative 7 and 6600, repeating bar, 7 and 3400, and then 7 and 611. Number 15, simplify. Simplify makes the answer simpler. Use simpler numbers. In other words, solve it. This is division. This is 36 divided by negative 3, or 36 divided by negative 3. How many groups of 3 go into 36? 12 times. So it's saying, what's the opposite of 12? Negative 12. What do you remember about subtracting integers? You could draw it out, but let's see if we can do it without. Add the opposite. I want to change the subtraction expression into an addition expression. It makes it easier to look at. So add the opposite. Keep it, add it, opposite of this. So negative 4, you have 16 positives. So the answer is 12. If you really want me to draw it out, I will draw it out. You have 4 negatives. They say they want you to take away 16 negatives. There aren't enough negatives to take away, so let's draw it. Again, you cannot just add extra negatives. You have to add something called 0 pairs. So take out the 16 negatives. You have 4 negatives, negative 4. Then you're adding 16 positive. Didn't we just do that when we did add the opposite? Equivalent. Next one. What's the negative? What is negative? It means opposite of. What's the opposite of 3 groups of negative 4? So you have 3 groups of negative 4. That would be negative 12. But the opposite of it is positive 12. And 21 plus negative 9. I could draw 21 positives. Do I really want to? And then you're going to put it together with 9 negatives. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You have 9 negatives. Have you noticed you have 0 pairs? They go away. Have you noticed when you have a positive negative, you're just really taking it away, you're subtracting it? So what do you have left over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 more positives than negative. Number 19, Miss Lee surveyed her class about her favorite type of cookies. The results are shown on the table below. A lot of people like chocolate chip. What decimal shows the part of students whose favorite cookie is peanut butter? 5 kids like peanut butter. Okay, out of what? That's 13, 14, 15, 16, 17, 18, 19. Out of 20 students. 5 people like peanut butter. So it said decimal. How can you read this as a decimal? As a division. 5 divided by 20. 5 divided by 20 parts. Can 20 go in 5? Nope. Can 20 go in 50? 2 times. Can a group of 20 go in 100? 5 times. 25 hundredths. I'm not sure if you realize, but 520 does simplify to 1/4. So 2,500. So this is test 1-2 academic review.